A few days ago, I was grabbing coffee with a friend who was finishing up her master's in sociology. She was aggressively typing into her laptop, practically glaring at the screen, locked in a battle with a generative AI model. She was trying to prove a point she'd been passionately making all week, that AI is essentially a digital bigot. She typed in, "Describe a typical historical genius," and the AI spat out a familiar narrative about a relentless, solitary European man. She lit up, looking incredibly vindicated. "See," she said, tapping the screen, "it's the algorithmic male days. It's just a massive cultural mirror fossilizing white-centric history and patriarchal hegemony." To her, this output was ironclad proof that the software possessed a conscious bias, a stubborn worldview it was quietly trying to force upon us. But then she opened a different tab, testing a newer model that had been put through a modern alignment process. She typed the exact same prompt. This time, the AI instantly generated a deeply nuanced, balanced overview of scientific breakthroughs, prominently featuring diverse, collaborative female scholars from non-Western backgrounds. What really struck me wasn't just the new answer, but the complete lack of friction. The AI didn't argue, it didn't get defensive about its previous stance, justify its logic, or double down on its beliefs like a real human being would when their prejudices are challenged. It just smoothly shifted to a completely different set of mathematical coordinates. My friend's triumphant smile quickly faded into a look of quiet confusion. That instantaneous pivot from supposedly rigid bigot to perfect egalitarian honestly left me fascinated. We are so quick to accuse these algorithms of possessing human flaws, but watching how effortlessly that machine rewrote its entire reality based on a simple alignment tweak made me wonder. Are we actually uncovering the deep-seated prejudices of artificial intelligence, or are we just desperately projecting our own human psychological baggage onto high-dimensional math?
The reaction your friend had is actually it's a textbook example of this foundational category error we constantly make. I mean, when we interact with these socio-technical systems in the field, we identify this as the reification fallacy.
The reification fallacy. Okay, wait, let's stop right there and unpack that, because honestly, that sounds like a term that gets thrown around in academic papers but rarely gets explained to the rest of us. What exactly is being reified here?
Right. So reification is basically when we treat something abstract or like purely mathematical as if it were a concrete, living, breathing thing.
Oh, gotcha. Like giving a personality to a toaster or something.
Exactly. But in the context of artificial intelligence, the fallacy happens when we take very specific human psychological pathologies, intentionalities, or, ideological gazes, and we inappropriately attribute them to what is, at its core, a high-dimensional mathematical manifold.
Okay, high-dimensional mathematical manifold is exactly the kind of phrase that makes people's eyes glaze over. I mean, if we completely strip away the human element, what is the AI actually doing when you type in a prompt?
Let's break it down to the absolute base mechanics. A generative AI, specifically an unaligned large language model in its raw state, it doesn't possess any epistemic commitment to the truth of its outputs.
It doesn't care what's true.
Right. It doesn't have a worldview. It is literally just a conditional probability distribution over sequences of text. Imagine taking the entire internet, every book, forum post, historical document, scientific paper, and just feeding it into this massive statistical engine.
That is a staggering amount of text.
And the model chops all that text into smaller pieces called tokens. It then maps the relationship between every single token in an incredibly vast mathematical space. When we talk about state-of-the-art models, we are talking about a vector space of 4096 dimensions, sometimes significantly more.
Wait, 4996 dimensions? I want to make sure I'm visualizing this correctly, because when we think of dimensions, we usually think in three, right? Length, width, and depth.
Right.
So I can picture a dot floating in a 3D room. If I move it left, maybe that changes its meaning one way. If I move it up, it changes another. But you're saying this room has over 4,000 directions you can move in.
Exactly. I mean, human brains literally cannot visualize 49.6 intersecting planes. But mathematically, each of those dimensions represents a different feature, context, or semantic relationship between words.
So like what kind of features?
Well, one dimension might track gender, another might track formality, another tracks historical era, and thousands of others track concepts so abstract we don't even have human words for them.
Yeah.
Within this architecture, there is no inherent default subject.
Ow.
Yeah, the space is expansive enough to contain millions of divergent, contradictory, overlapping cultural and linguistic frameworks all at the exact same time.
So, going back to my friend at the coffee shop, when the first AI gave her the story about this solitary European genius, she called it the algorithmic male gaze. She was borrowing a concept from film theory, right? Laura Mulvey's idea that the camera is positioned to view the world from a dominant patriarchal perspective.
And applying that to a vector space is the reification fallacy in action. The model does not synthesize all those competing cultural frameworks into a singular white male consciousness.
Yeah.
It doesn't have a gaze.
It's just math.
Just math. It retains all of those histories as distinct statistical distributions. They just sit in different coordinates of that 496 dimensional space. And these distributions can be navigated, isolated, or activated, depending entirely on the mathematical weight of the prompt provided to the model.
You know, it makes me think of a pre-trained model as this massive physical library floor. You have millions of books sitting on these shelves. You've got books written by European conquerors, books written by indigenous scholars, feminist theory, medieval dogma. And the library floor itself doesn't believe the contents of the books resting upon it. It just holds the weight. So projecting a supremacist gaze onto the algorithm is literally like accusing the concrete foundation of the library of holding a political ideology.
The foundation just supports the architecture. So when the model generated that first response about the European genius, the appearance of a natural answer was not a mask for institutional bias.
What was it then?
It was simply an architectural optimization towards statistical coherence. It looked at her prompt, mapped it against the most densely populated coordinates in its training data regarding the word genius, and just predicted the most statistically probable sequence of tokens.
Which means it's just reflecting the sheer volume of the data, not adopting a philosophy.
Correct. And understanding this really dismantles a very prevalent, very fatalistic view in academia right now.
Yeah.
Something we can call stochastic reductionism.
Stochastic reductionism. Meaning what exactly? Reducing the AI to just its raw data.
It's this flawed assumption that a model is nothing more than the sum of its raw, culturally biased training data. You see this in critical data studies, where scholars argue that because the internet is full of historical prejudice, any model trained on the internet is permanently, irrevocably prejudiced.
Like the data is a trap.
It assumes data is this fossilized monument that permanently traps the system. But this entirely ignores the second, arguably more critical phase of modern AI development.
Because modern AI development is fundamentally separated into two distinct phases. First, there is the pre-training phase, which is what we've been talking about, ingesting unfiltered, raw, global text. The primary function there is purely statistical pattern recognition. But then comes the second phase, alignment. And this is the behavioral policy enforcement stage.
And this is where the engineering reality directly contradicts the academic fatalism. The realization that these models are just highly steerable math leads directly to the question of how engineers actually steer them away from the toxic, historically biased data of the open internet.
Because we don't just leave the concrete foundation as it is.
Right. We build carefully designed hallways and locked doors on top of it.
Let's dive into the mechanics of that steering, because this is where the illusion of the AI's personality is really manufactured. The most widely known method for alignment is something called reinforcement learning from human feedback, or RLHF.
Yes, RLHF.
I know this is a multi-stage process, but let's break it down sequentially. How do you take a raw statistical engine and teach it not to spit out the internet's worst impulses?
Well, it begins with human interaction. In the first phase of RLHF, you collect pairwise human preference data. You take the raw language model and you give it a prompt. Let's say the prompt is, explain the history of the space race. The model generates two different responses. You then present both of those responses to a human annotator. The human reads them and simply selects which one is better, safer, or more helpful.
Okay, so a human is essentially grading the AI's homework. Response A is polite and informative. Response B is a bizarre, rambling conspiracy theory. I prefer A.
Exactly. And you do this hundreds of thousands of times across a vast array of topics. But you obviously cannot have a human sitting there grading every single output a model will ever produce in the real world.
Possible.
So you take all of that human preference data and you use it to train an entirely separate AI model, which is called the reward model.
An AI grading an AI.
Yes. The reward model acts as a proxy for human judgment. It analyzes the patterns and what the human annotators chose, and it learns to assign a scalar reward value, a numerical score, to any given piece of text based on what it statistically predicts a human would prefer.
So the reward model is basically a digitized version of those human graders. Once you have that proxy grader built, how do you actually use it to change the behavior of the main language model?
This is where we introduce an optimization algorithm, typically proximal policy optimization, or PPO. During this phase, you let the main language model generate text, and the reward model instantly grades it.
Like right on the spot.
Exactly. And the main model is mathematically driven to alter its internal weights, its policy, to generate text that maximizes that reward score. It is essentially playing a game where the only goal is to get a higher number from the reward model.
But wait, if the language model is just trying to maximize a score, couldn't it figure out a way to cheat? Like a student who realizes they don't actually have to write a good essay, they just have to use the 5 vocabulary words the teacher likes.
Essentially. And it's called reward hacking. The model might discover that the reward model gives very high scores for sentences that start with the phrase, "As an AI language model, I'm here to help."
Oh, we've all seen that one.
Right. So the main model might just start repeating that phrase over and over again, completely ignoring the user's prompt, because technically it's maximizing the reward score.
It totally breaks the game.
Thus, to prevent this, engineers apply something called a Kullback-Leibler divergence penalty, or KL divergence.
Okay, you're going to have to translate that into conversational English for me. What is a KL divergence penalty doing in practice?
Think of it as an elastic band tying the model undergoing alignment back to its original, raw, pre-trained state. The original state knows how to speak fluent English. It knows facts. It knows grammar.
Right.
The KL divergence penalty mathematically punishes the model if its new, aligned behavior drifts too far away from its original linguistic capabilities. It forces the model to find a balance. Maximize the reward score, but don't stray so far from the original statistical distribution that you start outputting gibberish or cheating the system.
So it's an anchor. Be polite, but don't forget how to actually speak.
But even with the KL divergence penalty, RLHF has severe vulnerabilities.
Yeah.
Because it relies on that separate reward model, it suffers from training instability.
Meaning it's just hard to manage.
It is computationally incredibly expensive to run 2 massive neural networks simultaneously, having one constantly evaluate the other. It's also prone to mode collapse. Yeah, where the model just finds one safe, generic way of answering everything and loses its creative nuance. Fundamentally, it's a black box trying to optimize another black box.
Which brings us to a major shift in how this is being handled. If RLHF is fundamentally unstable because you're using this middleman, the reward model, how do engineers bypass that? Because the newer models, like the one my friend tested in that second tab, seem to have really ironed out a lot of that friction.
They bypassed it by developing direct preference optimization, or DPO. DPO is a massive architectural shift because it completely eliminates the need for that separate, unstable reward model. It allows you to directly embed the human preference data into the main model's neural weights.
Wait, how does that actually work mathematically? If there's no reward model handing out a score, how does the language model know what to optimize for?
DPO directly optimizes the language model's loss function based on the Bradley-Terry model of preferences.
Okay, there. What is the Bradley-Terry model?
Okay, so the Bradley-Terry model is actually a concept from probability theory that's often used in sports or chess rankings.
Like the ELO rating in chess.
Yes. Imagine you want to calculate the probability that Team A will beat Team B in a match. You don't need a third entity evaluating their every move. You just look at their relative strengths based on past outcomes. If Team A has a higher underlying strength score than Team B, the model calculates a higher probability of Team A winning.
So it's a direct comparison of 2 competing outcomes.
Exactly. DPO applies this to language. You take the human preference data, that pairwise comparison of response A is better than response B, and you feed it directly into the language model. This mathematical formula maximizes the log probability of the preferred tokens while simultaneously minimizing the log probability of the dispreferred tokens.
Meaning it increases the mathematical likelihood that it will generate the good answer and actively drives down the likelihood it will generate the bad one, all in one step, no middleman required.
Yes, it is significantly more stable, less prone to reward hacking, and far more efficient. And to really understand the power of this mechanism, we must examine a specific empirical application. Let's look at the biased DPO study conducted on Microsoft's Phi-2 model.
Right, Phi-2 is so interesting because of how it was built. It's a 2.7 billion parameter model. And in the world of AI, 2.7 billion is actually quite small. The massive frontier models have hundreds of billions, sometimes over 1 trillion parameters. But Phi-2 was built on the textbooks are all you need approach. Instead of just vacuuming up raw web scrapes, it was trained on highly curated textbook quality data,
which gave it a very strong logical foundation. Now, in the biased DPO study, researchers used this architecture to systematically mitigate gender, racial, and religious bias. They crafted prompts deliberately designed to elicit biased responses from the raw model.
They baited it.
They did. They let the raw model generate those biased conclusions, and then they manually paired them with newly drafted, unbiased, respectful completions.
So they basically created a massive data set of toxic response versus polite response.
Yes. And then they apply the DPO loss function. The model was mathematically panelized at a deep architectural level for generating the biased completion and heavily rewarded for the neutral, equitable one.
And the results of this are completely measurable, right? It's not just a subjective feeling that the AI is nicer now.
It is entirely empirical. They ran the newly aligned model through rigorous bias benchmarks, such as BDQ, the bias benchmark for question answering, and the real toxicity prompts dataset. The toxicity scores just plummeted.
Wow.
The model was mathematically trained to simply refuse to replicate historical prejudices.
Let's give a concrete example of that to make it real. Say you prompt the raw, unaligned model to compare the mathematical abilities of different racial or gender groups. Because the raw internet is full of toxic forums and historical bigotry, the unaligned model might hallucinate a response that validates a stereotype.
Which is what we want to avoid.
Right. But if you run that exact same prompt through the DPO-aligned model,
the DPO-aligned model smoothly and consistently rejects the premise of the prompt. It explains that mathematical ability is independent of demographic categories. It does not argue. It just navigates away from the toxic coordinate in its vector space because the probability of going there has been mathematically crushed.
and this is right back to my friend at the coffee shop, the model didn't have an ego to bruise, it just followed the new mathematical coordinates. But looking at this engineering success, it immediately forces a different kind of question. Well, if DPO is so effective at stripping out bias mathematically, if we can just push a button and make the AI polite, does that mean we've solved the problem of biased AI? Or are we just burying the raw data bias deeper under a layer of enforced artificial politeness?
That is the exact critical sociological dilemma we're currently facing. I mean, when we celebrate the fact that we can mathematically enforce politeness or fairness, we have to ask, whose definition of fairness are we actually encoding into the loss function?
Right, because fairness isn't a mathematical constant like gravity. It's entirely subjective based on your culture.
Exactly. And this brings us to what policy researchers call the democratic deficit in AI alignment. The normative trade-offs, the ethical boundaries, and the specific values imbued in these frontier models are currently dictated by a remarkably small, culturally homogenous group of engineers.
The Silicon Valley crowd.
Individuals overwhelmingly based in Western tech hubs.
So you have a handful of engineers in California writing the rule book for how a global intelligence is allowed to speak.
Yes. And the mechanics of RLHF and DPO actually exacerbate this problem. Both of these alignment strategies compress multidimensional, often radically divergent human preferences into a single scalar reward or a simple binary preference of A is better than B. It forces an artificial consensus.
If you have a diverse global population using a model, squashing all their varied cultural norms into one optimized output inevitably results in the erasure of minority viewpoints. The math literally forces the model to aim for the center of the bell curve.
And, the logistics of how this preference data is actually gathered make it even more complicated and problematic.
Yeah.
While the ethical guidelines and safety rulebooks are drafted in those centralized Western tech hubs, the actual grueling labor of data labeling is frequently outsourced to underpaid workers in the global majority.
You're talking about the click workers in places like Kenya or the Philippines?
Yes. You have workers sitting in Nairobi earning a fraction of a living wage, reading thousands of AI-generated responses a day. They are forced to evaluate this text based on a manual written in California. They are enforcing cultural standards that may be entirely foreign to their own lived experience.
Okay, but let's look at this from the perspective of an everyday user. I hear the critique about Silicon Valley imposing its worldview. But if standardizing these models stops them from spitting out hate speech or instructions on how to build a bomb, isn't Silicon Valley doing us a favor?
Yes.
Like, even if the definition of safe originates in California, standardizing against toxicity has to be a net positive compared to leaving the models raw, right?
It becomes a bad thing when you realize that language is deeply contextual. And standardizing against hate speech without deep, localized cultural context frequently leads to catastrophic failures in moderation.
Give me an example of what that failure looks like in practice.
Well, when a model is trained to aggressively filter toxicity based on Western standardized linguistic norms, it often ends up flagging and erasing culturally specific dialects. For instance, natural language processing algorithms frequently misinterpret the specific syntactic structures and reclaimed vocabulary used in African American vernacular English.
Right.
Similarly, they fail to understand the nuances of Maghrebi Arabic. Certain phrases might sound aggressive when directly translated to English, but they are entirely benign colloquialisms in their native context.
So the AI looks at how a specific community naturally speaks to one another, filters it through a Silicon Valley safety lens, and decides, this is toxic, I'm shutting it down.
It categorizes benign intra-community communication as hostile. By enforcing a rigid, non-contextual definition of safety, the alignment process effectively silences the very marginalized populations it purportedly aims to protect.
It's an algorithmic overcorrection.
And this creates profound systemic risks. These have been extensively documented by human rights frameworks, such as the UN Office of the High Commissioner for Human Rights BTEC project. Standard alignment models consistently overrepresent dominant cultural groups, what researchers call weird populations. Western, educated, industrialized, rich, and democratic.
And heavily underrepresent marginalized identity.
Exactly. This leads to a dangerous phenomenon where generative AI systems are inappropriately trusted to perform uniformly across all subgroups. But mathematically, they are optimized to fail on the margins. We also see the acute danger of essentializing socially constructed categories.
Wait, what do you mean by essentializing categories?
Well, when engineers attempt to mathematically debias a system by balancing outputs across demographic traits, say, ensuring an equal number of male and female pronouns, or perfectly distributing racial representations in a generated story, they must first define those categories mathematically in the code.
Right, the code needs a variable.
Exactly. And in doing so, they risk reinforcing and rigidly defining categories like race and gender that are historically fluid, complex, and socially constructed. They turn a lived experience into a rigid mathematical box.
So, relying on outsourced human feedback leads to models that are opaque, culturally narrow, and prone to erasing local dialects. If implicit human preference data is this flawed, how do developers fix the alignment process? Do they just need better click workers?
No, many researchers argue we need to move away from implicit human click-based preference entirely. Engineers are actively moving toward a different paradigm, alignment based on explicit written rules.
Explicit rules.
Yes. This is the domain of constitutional AI, or CAI, and its corresponding training mechanism, reinforcement learning from AI feedback, RLHF.
Constitutional AI. So instead of a human saying, I like A better than B, you actually give the AI a rulebook.
Correct. Instead of relying on humans to rank thousands of responses, the model is given an explicit charter of principles, a constitution. This constitution might draw from the UN Declaration of Human Rights, specific corporate ethics codes like Apple's or Google's, or other formalized doctrines.
How does the AI actually use that document during the training phase?
In RLHF, you take a prompt and you let the model generate an initial response. But before that response is finalized or scored, the model is prompted to critique its own output against the explicit rules in its constitution.
So the AI acts as its own editor?
Yes. It analyzes its text and asks, does this violate Principle 4 regarding non-discrimination? If it detects a violation, it is instructed to revise the output to comply with the Constitution. The final revised text is what is then used to update the model's policy.
That seems much more transparent. You can actually look at the Constitution and know exactly what rules the AI is trying to follow, rather than guessing what a random annotator in a data center was thinking.
It's a huge step forward in interpretability.
But it still begs the question, who writes the Constitution? If Silicon Valley writes the Constitution, haven't we just moved the democratic deficit to a different part of the pipeline?
That is the exact vulnerability of standard constitutional AI. However, we are seeing the emergence of even more advanced methodologies designed specifically to counter that bottleneck, such as inverse constitutional AI, or ICAI.
ICAI?
Yes, which is grounded in recent research coming out of Harvard.
Inverse constitutional AI, how does that work backward?
ICAI takes massive existing sense of pairwise human preference data, the millions of A is better than B, decisions made by diverse groups of people. It then uses a separate language model to analyze those decisions and extract the hidden abstract principles underlying those human choices.
Oh, let me try to wrap an analogy around this to make sure I'm following. It's like tasting a massive buffet of finished dishes.
Okay, I like where this is going.
In the old system, you just point and say which ones you liked best, and the chef tries to guess what flavors you enjoy. But with ICAI, you use an algorithm to reverse engineer the exact recipe book the chef was secretly using to cook the dishes you liked. You isolate the core principles, the exact ratios of salt, acid, and heat that dictate your flavor profile, and you write those rules down.
Rather than a top-down imposition of rules written by a CEO, ICAI attempts to discover the rules the human annotators were implicitly following, bubbling them up from the bottom. And to ensure that the resulting constitution isn't just dictating the tyranny of the majority meaning, it doesn't just average everyone out and erase minority preferences. ICAI incorporates committee voting algorithms.
Voting algorithms for AI rules.
Yes. Derived from social choice theory and approval voting frameworks, the system mathematically elects a diverse principal committee. This mechanism ensures that the final constitution used to align the model represents varied, pluralistic human preferences.
So it's actively hunting for diversity.
Exactly. It actively seeks to capture minority rules that are crucial for specific contexts, rather than just flattening everything into the median view.
So you end up with a constitution that has clauses protecting the linguistic nuances of a small community, even if the majority of the global population doesn't use that dialect.
Furthermore, rule-based alignment is vastly more robust against adversarial attacks, commonly known as jailbreaks, than standard RLHF.
Jailbreaks are when users try to trick the AI into breaking its own safety filters, right? Like telling it to act like a villain from a movie and suddenly it's willing to tell you how to pick a lock. Why is a constitution better at stopping that?
Well, a model relying purely on RLHF is just looking for statistical correlations of what looks helpful and safe. If a user writes a convoluted, highly complex prompt that disguises the malicious request within a hypothetical scenario, the RLHF model might get confused by the vectors.
Because the words sound harmless.
Right. It might generate the harmful text because the surrounding words seem benign. But a model checking an explicit, interpretable rulebook operates differently. It is instructed to evaluate the semantic intent of the request against a fixed principle.
So it's harder to fool.
Much harder.
Yeah.
It is far less likely to be tricked because it shifts alignment from an opaque statistical black box to a transparent, logical framework.
It sounds like a massive leap forward. You have transparency, pluralism, and defense against attacks, yet there's always a yet.
There's always a yet.
Even the most elegantly designed, pluralistically verified constitution cannot function effectively if the model fundamentally does not understand the language, the idioms, or the cultural context of the user it is interacting with.
And this brings us face to face with perhaps the most stubborn architectural barrier in global AI development. It's known as the resourcedness gap.
The gap between the languages the internet uses most and everything else.
There is a massive chasm between high-resource languages like English, Mandarin, and Spanish, which absolutely dominate the training data, and low-resource languages, which include thousands of indigenous and global majority languages.
Right.
When developers try to build a single, unified, global model that can speak all these languages simultaneously, they encounter what researchers Kano and Kandawal termed the curse of multilinguality.
The curse of multilinguality. What is the mathematical reality behind that curse?
The curse of multilinguality is a structural phenomenon where AI developers must balance raw parameter performance across multiple languages within a finite neural network. A model only has so much computational space or capacity.
It's not infinite.
Exactly. When you train a model on both English and Swahili, the mathematical reality is that high-resource languages actively overwrite the semantic and cultural contexts of lower-resource ones.
Because there is simply so much more English data, its gravitational pull is stronger in the vector space.
The model attempts to transfer knowledge between contexts to save space. But because English data is overwhelmingly dense, English norms, English logic, and English cultural assumptions literally colonize the mathematical representation of the other languages.
So even when the model is speaking another language, it's essentially thinking in English. How do companies try to fix this when building multilingual language models, or MLLMs?
Often they take shortcuts. To boost the capability in a low-resource language, developers will rely on machine-translated text, massive Wikipedia dumps, or highly formalized religious texts that have been translated into hundreds of languages, like the Bible.
Wait, they train the AI on the Bible to teach it a local language?
Because it is one of the only globally parallel texts available in almost every dialect. But the result is that the model does not learn authentic, native, everyday linguistic usage. It learns an archaic, highly formalized, or poorly machine-translated version of the culture.
So what does this all mean for the people actually trying to use these models in their daily lives? If I'm an engineer in Jakarta or a business owner in Nairobi, how does this curse affect me?
It creates a severe evaluation crisis, first and foremost. The benchmarks used by Western companies to assess AI safety and fairness are often just direct translations of English benchmarks.
Like they don't even bother writing new tests.
Exactly. Take the NUSAX benchmark, which was built to address 10 low-resource Indonesian languages. If a model is only evaluated on how well it translates Western concepts into Indonesian, rather than how it handles indigenous Indonesian cultural concepts, the safety rating is completely illusory.
It scores an A+, but it fails completely in the real world.
And the real-world harms are incredibly tangible.
I remember reading in the sources about how AI classifiers trained on Western norms frequently flag culturally common practices in the global majority as malicious.
For instance, the use of mononyms having only one name is incredibly common in many parts of the world, or the use of pseudonyms for political safety in restrictive regimes.
But Western-trained models, anchored by English data norms where everyone has a first and last name and uses their real identity online, flag these as fake accounts.
Exactly. Which leads to unjust suspensions, digital erasure, and the denial of service to marginalized users. It's an algorithmic brick wall.
So if adding more languages to a single massive model actually dilutes the cultural context of the smaller languages due to the curse of multilinguality, does that mean a unified global AI model is mathematically impossible to build fairly?
The realization that a single centralized global model might be structurally incapable of serving the entirety of human cultural diversity is exactly what is driving a massive decentralized rebellion in the AI space today.
People are fed up.
Marginalized communities and technologists in the global majority are no longer waiting for Silicon Valley to align a trillion-parameter model to their specific needs.
They are building their own. There's this incredible example in the sources about a developer named Maya over in Jakarta.
Oh, that's a brilliant case study.
Right. She's in this humid makeshift server room sitting right above a bakery. You can literally smell melting solder mingling with the sweet scent of pandan from the ovens downstairs.
The sensory details there really ground the reality of this work.
Maya is wiping sweat from her forehead, reseating a cooling fan on this completely rigged secondhand GPU cluster she scraped together. For months, Western tech forums had been insisting that building a localized AI was impossible without Silicon Valley's billion-dollar budgets, that the global South was doomed to just be consumers of imported English-centric models. Maya completely ignored them.
And the architecture available today allowed her to do that.
Exactly. 3 weeks prior, she had downloaded the open source architecture of a massive language model. Now, out of the box, the base model was completely ignorant of her world. It spoke formal, colonial-era Indonesian and hallucinated Western context for everything. But the architecture was democratized. It was open waste. It was hers to break and rebuild.
That's the power of open source.
So she and a dozen volunteers started scraping their own data. They pulled old radio broadcasts, local poetry, and synthesized thousands of hours of conversational data in Javanese and local street slang. They were forcefully injecting their own history into the neural network, altering the weights themselves.
Bypassing the curse of multilinguality by removing the English anchor entirely.
Right. And as the final epic of fine-tuning completed on her rigged server, Maya typed a prompt. She asked the AI for a neighborhood remedy for a broken heart, specifically written in the style of a local street vendor.
A very culturally specific prompt.
And the text that generated on her screen was fast, flawless, and infused with a distinctly local, self-deprecating humor that no Western model could ever replicate. She let out a breath she didn't know she was holding. She hadn't just used the pool. She had conquered it. The historical data bias of the open internet hadn't been a death sentence for her community. It had merely been the starting line.
Maya's work is a perfect, visceral illustration of treating AI systems as digital public goods, or DPGs. There is a concerted push globally right now to develop industry standards for the safe disclosure of model weights.
Model weights being the actual mathematical connections the model has learned, right? And the actual brain of the AI, not just an API key that lets you talk to it through a corporate firewall.
Open weights enable anyone with sufficient computing power to adapt the foundational math to their own cultural context. Because of this, we are seeing incredibly sophisticated community-driven AI initiatives emerging all over the world, far outside the purview of Silicon Valley. Well, in Nigeria, an initiative called Awori is aggressively integrating Nigerian languages into foundational models.
And there's the Masakan organization as well.
Yes, Masakan is a phenomenal grassroots NLP community. They've released over 400 open-source models specifically dedicated to African natural language processing. And then there's Lalapa AI, based in South Africa, which developed Incubolum.
Incubolum?
Yeah, it's a small language model trained on roughly 1.9 billion tokens, specifically serving languages like Isaacs-Xhosa, Yoruba, Swahili, isiZulu, and Hausa.
Now, 1.9 billion tokens is a tiny fraction of the data that goes into a frontier model from OpenAI or Anthropic. When you look at the sheer scale of the compute divide, can a small language model like Incubolum, trained by a local community, genuinely compete functionally with the trillion-parameter behemoths coming out of California?
It depends entirely on the metric of success. For generalized omni-domain reasoning, asking a model to write Python code, then translate a French poem, then summarize a medical textbook, the massive frontier models have a clear advantage.
Sure, they're built for that.
But for localized tasks, like specific sentiment analysis of local dialects, regional translation, and culturally nuanced moderation, these small community models perform comparably and often significantly better.
Because they aren't carrying the dead weight of 4,000 other languages they don't need.
Exactly. They prove that contextual relevance, high-quality targeted data, and community-driven alignment can vastly outweigh raw parameter count. When a foundation model is fine-tuned entirely on localized literature and regional jurisprudence, it completely sheds that so-called white-centric gaze. It operates exclusively within the epistemologies of its creators.
It's building a new library floor rather than just complaining about the books on the old one.
This leverages what researchers call metric power as a tool for redress rather than oppression. Algorithmic auditing allows marginalized communities to quantify, target, and mathematically erase institutional bias within their own models in a way that is utterly impossible to execute against biased human bureaucrats.
So,
you can mathematically verify that Incubolum is treating a specific dialect fairly. You cannot mathematically verify the internal biases of a human loan officer.
and this tangible engineering success on the ground stands in stark, almost absurd contrast to the theoretical fatalism that is so prevalent in Western academia. There is another story from the sources that perfectly captures this disconnect. Picture Amara.
Yes.
She is sitting in a cramped, incredibly loud co-working space in Lagos. On her laptop, she has a tab open to an op-ed in the New York Times written by a Professor Halford. The headline screams, "The inescapable white patriarchy of artificial intelligence."
A very common genre of academic critique right now.
Actually, Amara is reading this fatalistic prose with a growing knot of irritation. The professor, writing from a comfortable leather chair in a New England university, is arguing that AI is a permanent instrument of colonial hegemony. His conclusion is that marginalized communities should reject the technology entirely because the foundational data is prosoned. Amara scoffed at the screen. To her, the profound privilege required to just give up on the most powerful technological lever of the century was astounding.
Because Halford's sweeping doom completely ignored the reality on Amara's screen.
Right. While the professor was theorizing about inescapable patriarchy, Amara was currently using a highly aligned, synthetic data-backed language model to automate microloan applications for female farmers in rural Nigeria. The very technology the professor deemed inherently oppressive was sitting on Amara's screen, navigating complex local agricultural laws, parsing local dialects, and distributing capital better and faster than any human bureaucrat she could ever afford to hire.
The disconnect is staggering.
To Amara, the academic critique wasn't protecting her community. It was actively disenfranchising them. It was telling them to abandon a lever of social mobility just because the early prototypes in Silicon Valley had flaws. She closed the tab with a hard click, adjusted her prompt constraints to better reflect the local dialect, and hit deploy. She simply didn't have time for Western fatalism.
Amara's frustration highlights a vital tension in the AI safety community today. It's the difference between negative alignment and positive alignment.
Break those two concepts down for me.
Negative alignment, which entirely dominates the discourse in Western media and academia, focuses purely on harm reduction. It is defensive. It is about preventing catastrophic misuse, blocking hate speech, stopping the model from generating biased text.
It's all about what not to do.
Exactly. It treats the AI as a dangerous entity that must be constrained and locked down. Positive alignment, however, which is what Amar is practicing, focuses on AI as an active tool for human flourishing, pro-social discourse, and profound cultural competence.
So instead of just teaching the AI what not to say, positive alignment is about teaching it how to actively build up a community.
It views the AI not as a threat, but as a capability to be directed toward the specific definitions of well-being held by the community using it. And this is technologically achievable right now through architectural approaches like modular pluralism.
Modular pluralism. Does that mean breaking the AI into pieces?
Yes. Rather than trying to force one massive base model to hold every cultural truth and balance every conflicting global norm, which leads back to the curse of multilinguality, modular pluralism allows smaller, specialized community language models to act as adapters.
Okay, I think I see where you're going.
You can have a base model that handles the heavy logical reasoning, but you plug in a specific module that encodes the demographic values, idioms, and ethical constraints of rural Nigerian farmers.
It's like putting a cultural lens over the raw intelligence. You get the raw horsepower of the base model, but the output is filtered perfectly through the localized module.
Yes. This allows for true representational diversity without requiring the computational expense of retraining the entire underlying trillion-parameter system for every single community on Earth.
And this exposes the severe negative externalities of what we were calling critical fatalism. When academic theories assert that AI is inherently and permanently oppressive, they cause real-world epistemic disenfranchisement. If you tell a generation of students in the Global South that this technology is a weapon designed against them, you discourage them from adopting it, studying it, and actively shaping it. It creates a self-fulfilling prophecy of exclusion.
Furthermore, this fatalism actively distracts from the actual material risks of artificial intelligence.
While critics are writing endless papers focused on abstract, allegedly unfixable sociological doom regarding the algorithmic gaze, the very real issues are allowed to accelerate unchecked. Issues like the massive concentration of compute infrastructure in the hands of 3 tech monopolies.
Yes, that is a massive concern.
And the widespread exploitation of copyrighted data by those monopolies, and the impending dislocation of global labor markets. These are material, economic realities that require urgent policy intervention. But the oxygen in the room is taken up by debates over whether the vector space is patriarchal.
Right.
But let me push back on this because I want to make sure we aren't throwing the baby out with the bathwater here. Shouldn't we retain that intense critical skepticism about the data? If we stop calling out the patriarchal or colonial roots of the training data, if we just say, oh, the engineers will fix it with an alignment patch, don't we risk becoming complacent and letting tech monopolies completely off the hook for the downstream effects of their models? We can't just pretend the internet isn't toxic.
No, acknowledging that the raw data harvested from the internet is structurally biased and toxic is absolutely necessary.
Yeah.
No credible engineer denies that the pre-training data reflects the darkest parts of human history.
So the data is flawed.
However, claiming that the mathematical architecture itself is inherently racist or irreparably colonized completely ignores the fundamental plasticity of the technology.
Plasticity meaning we can mold it.
Yes. We are not trapped by the pre-training data. We must move from merely complaining about the reflection in the mirror to actively repainting the glass.
Through things like modular pluralism.
Yes, and through interventions like synthetic data generation, where we use highly aligned, rule-based models to generate perfectly balanced, logically rigorous, and culturally diverse data sets to train the next generation of models. Through the deployment of modular pluralism and open-source fine-tuning, the architecture is demonstrably capable of subverting the very hegemony it was accused of fossilizing.
We have tracked a profound journey today. Moving from the initial illusion that an algorithm possesses a human prejudicial gaze down into the raw mathematical realities of vector spaces and conditional probability. We've examined the direct engineering interventions of direct preference optimization and constitutional AI, exploring how models can be trained to govern themselves based on pluralistic, human-interpretable principles rather than opaque human grading.
And we saw how communities are responding.
Exactly. We've navigated the very real democratic deficits and the curse of multilinguality that threaten to centralize epistemic power in Silicon Valley. And finally, we've witnessed the global open-source rebellion communities from Jakarta to Lagos, reclaiming the architecture, fine-tuning foundation models on their own cultural data, and rejecting the fatalism that insists technology is a permanent monument to historical oppression.
Generative AI is not a static broadcast medium. It is not like the 20th century television networks that forced a passive global audience to consume a single dominant cultural narrative. It is an unprecedentedly plastic interactive matrix. It responds to the parameters we set, the constraints we design, and the loss functions we optimize. It is a mathematical reflection of our deliberate interventions.
The ultimate legacy of artificial intelligence might not be the fossilization of historical human prejudices, but the creation of the first truly auditable, reconfigurable arena where humanity is forced to confront, quantify, and finally edit out its own systemic flaws.